All right, you have heard repeatedly that raster analysis is simpler than vector analysis. And I'm just going to warn you that this might not seem that way right this minute, but let's go over the different types of raster analysis. We're going to talk about 5 main types of raster analysis: local, zonal, focal, and global statistics, and reclassification. And I just want to note here that global statistics, I just expect you to know that on a very basic level for this class. Local functions are the most basic raster functions. These are raster overlays where each cell only interacts with the cells that share its spatial location. Here are some examples. Let's think of a raster or set of rasters with rainfall values for each cell. You can imagine this for the state of Oregon, where the cells with the highest values are those along the coast, with still pretty high values across the Willamette Valley, then slowly decreasing as you increase in elevation in the Cascades, and then drastically lower values on the eastern slopes of the Cascades and very low values across eastern Oregon. So let's say we have 12 rasters, one for each month of rainfall. We can do basic local statistics by adding up all of these months to get the local rainfall by location for all of Oregon. Things like adding, subtracting, multiplying, or dividing your different rasters. We can even do more complicated things like find the mean of all of the months or the range of all of the months by finding the minimum and maximum of each location for each month. We can also identify things like finding the months and locations that have rainfall that is greater than a certain amount or less than a certain amount, what we call relational operations. We can even do trigonometric or exponential or logarithmic calculations. In this class, though, we generally do fairly simple local operations, either arithmetic or statistical. This is probably the most common type of raster analysis that you'll encounter. Next up, we have zonal statistics. This allows you to create zones in one raster based on either a second raster or a vector polygon dataset. In this image on the right, the raster is the orange and yellow layer, and the zones here are shown with thick black lines. What you are able to do with zonal statistics is find, say, the average of whatever your raster is within that zone. So if we're talking about rainfall again, in this zone here, we could get the average number, the average rainfall across that zone. In this lab, you'll use this by finding which state has the highest variety of crops. I'm not going to spend much time on this slide that has tons of text, I know, but these are many of the different mathematical functions that you can perform using zonal statistics, from finding the mean within each zone, the majority, the maximum and minimum, the standard deviation, or the sum of all the cells in a particular zone. And remember that those zones could be things like a state polygon data set or another raster that has different zones, say land use or land cover, or maybe it's a county polygon data set, something like that. All right, next up is focal statistics. This one may be the hardest to understand on a video, but I'll post another video on this in hopes that it'll explain it decently. Focal functions are also called kernel convolution, which is what the guy on the other video I posted calls them. These are ultimately what is used to make filters work on things like Instagram or in Photoshop. Ultimately, this relies on a moving window, usually a 3x3 cell, that moves around your raster, creating a new raster. The most basic version of this is a blur, where we add up all of the values in a 3x3 window and then replace the middle value in that 3x3 window with that addition. In GIS, you may want to use this to add a blur or smooth out hard edges in your raster. Or you may want to enhance the contrast by adding a filter, which in essence is adding a high pass filter that kind of brings out edges. Or you might want to do this when you use terrain analysis, which I'll talk about in another video. In this example of a focal statistic function, we're using a majority filter, which has the effect of simplifying the map, eliminating smaller patches of isolated cells. Finally, a global operation is a process or function that is performed on each output cell using all of the cells of the input raster. This is often useful for finding the Euclidean distance of every cell from a single cell in a raster. It's also helpful for determining a cost surface. Again, don't worry about this one too much for this class. Just know that it exists. So let's go over these again. Local is the interaction between cells that overlap. Zonal is a calculation on the raster cells within zones that are designated by another raster or a polygon dataset. Focal is a moving window, sometimes called a kernel, in which you perform a set of calculations where the result of that calculation is placed in the center cell. And finally, global is a calculation performed on all the cells within one raster layer. More on that in GIS 2, which is beyond the scope of this course. And then finally, let's talk about reclassification. This allows us to replace certain values with other values to do some other type of raster analysis. For instance, we might want to reclassify our rainfall rasters into, say, classes of high, medium, and low. So what we would do is find all the cells that, say, have more than 50 inches of rain in a year and give them a 3, our highest rainfall class. Then we find all the places that have less than 20 inches of rain a year and give those a 1, our lowest rainfall class. And then everything else gets a 2 for the medium kind of amounts of rain in our area. We often use reclassify in combinations with other types of raster analysis like local, focal, or zonal statistics to find places that might have the high rainfall but are also in a particular zone. In this way, we're using the other functions to do things like site suitability. So think back to your Texas lab. How might you do that in a raster environment?